Rational function, we're going to find intercepts and asymptotes. Okay, first thing I always like to start out with is finding the vertical asymptote. And the vertical asymptote happens when the denominator equals 0. So 2x squared plus 5x minus 3 equals 0. That can be factored into 2x minus 1 and x plus 3 equaling 0. Check that middle term, negative 1, positive 6. We're good. So x equals 1/2 and x equals negative 3. Those are my vertical asymptotes because the denominator equals 0. Those are vertical asymptotes. For a horizontal asymptote, this is a first degree numerator and a second degree denominator. So the numerator is lower to the degree than the denominator. When that happens, the x-axis is a horizontal asymptote, and that equation is y equals 0. Remember, we have to have equations for asymptotes. Now we want to find the intersects. So the first thing we're going to do is find the y-intercept. Remember, x equals 0, so we're looking for the y value here. It is a point. When I do that, and I put x in all of these, I end up with x 1 over negative 3, so the y-intercept is negative 1/3. 0, negative 1/3 is that point. The x-intercept, so y equals 0, and you remember the only way this fraction can equal 0 is if the numerator equals 0. So x plus 1 has to equal 0, or x equals negative 1. So the point negative 1, 0 is the x-intercept. And then we did mention that it's possible for the graph to cross a horizontal or oblique asymptote, and here we have a horizontal. To find out if that happens, we take the rational function and make it equal whatever the horizontal asymptote is in this case. That would be 0, and we'd find out it's here. So yes, it intersects, and it intersects at negative 1, 0, because we're talking about where y equals 0. So we know from here already that it intersects. Find all the asymptotes, so let's find the vertical asymptote. First, for finding the vertical asymptote, let the denominator equal 0. So 2x will be negative 1, x is negative 1/2. That's my vertical asymptote. For the horizontal asymptote, since these are an equal function, we really look at the leading coefficients. We look right here. Y equals, horizontal asymptote will be a y equals leading asymptote, leading coefficients, 3/2. That's what we look at there. Now we need to find the y-intercept. So x is 0. We're looking for the y value here. Well, when I fill in 0 and 0, I'll end up with negative 4 over 1. So the y-intercept is at 0, negative 4. The x-intercept, let the denominator, we're looking for this, and y is 0, so the numerator equals 0. 3x minus 4 equals 0, so x will be 4/3. We have x-intercept. Now, does it intersect this axis? Let's find out. The question is, does it intersect the horizontal asymptote? I'll take the value of the horizontal asymptote, 3/2, and let it equal the function equals 2x plus 1. Well, look what happens here. We cross multiply. We'll end up with 6x plus 3 equals 6x minus 8. Subtract 6x, we'll end up with 3 equals -8. That's a no, so it does not intersect the horizontal asymptote. 1. Find all the asymptotes and intersects again. Vertical asymptote. The denominator equal to 0. So x equals 3 is my vertical asymptote. For this function, the numerator is higher degree than the denominator. So this does not have a horizontal asymptote. It has what's known as an oblique asymptote. When I find that, to find it, I take the numerator divided by the denominator. Oh, we can do synthetic division here. 3 on the outside, 2x squared, 0x and 5, 2, 6, 6, and 18, or 23. But we're only concerned about this part. And this part says 2x plus 6, and that equals y becomes our oblique asymptote. That's how we find an oblique asymptote. Now we'll look for the y-intersect. So x is 0. When I fill that in, 0, 0. 5 over -3, so -5/3 is my y-intersect. X-intersect. So the numerator has to be equal to 0. So I have 2x squared plus 5 equals 0. 2x squared equals -5. Oh, I'm going to end up with an I. So there's none for the x-intercept. Does it intersect the oblique asymptote? Let's find out. So we set the oblique asymptote, 2x plus 6 equal to the function 2x squared plus 5 over x minus 3. I can put a 1 underneath and cross multiply. So 2x squared, first terms. Outside terms give me -6x, and inside terms give me 6x. Oh, they're gone. And I'll have a -18 equals 2x squared plus 5. Oh, the 2x squareds are going to be out. -18 equals 5. Not in my world. So that would be a no.